Hello, thank you. And thank you, Matthias, for bringing me here. I'm happy to be here. I've already spent 2 days learning a lot from Alberto, and I'm hoping to spend the next 2 days learning a lot from you, so I'm looking forward to this. Okay, let's get to the talk. The talk is in 3 parts. The meat of the talk is part 3, but if I don't do part 1 and 2, it will look as though it fell out of the sky. So I need to motivate it. The subject, the original subject, was simplification, how to simplify software, and it has morphed into another approach, which you'll see in the last few slides. There are 2 messages that I'll deliver near the end, and I'll repeat them now. I'm going to introduce a flow model of applications. I'm going to be dealing mainly in the application layer, although you'll see connections later to the domain layer. But you're going to see a direct path from a pictorial description of an application to a running prototype. And it turns out that the particular model that this uses creates a space in which there's no coding required, and so there's an opportunity for the domain experts to participate in the development of a prototype. So there's an opportunity there perhaps to change the dynamics of the development group. This is just an opportunity at this point. So we'll start. My premise, and this has been going on for decades. The assumption is that this technology of software is becoming so important to everybody that it's important that it not be magic to everybody. There has to be a way for everybody to be able to have a sense of what's going on inside the applications that they're using. Well, it turns out that there's some history for that. There are 3 technologies that were originally the monopoly of priests, and they slowly evolved, and this took centuries. They slowly evolved that now they're property of elementary school children. Calendar, writing, and arithmetic. And so what I'm talking about may not happen in our lifetimes, but I see this trend, and I believe that it's important the software join this trend. Now, this slide is about 2 days old. It was a synthesis of something that Alberto was saying, and also a paper that I just read on the history of numbers. Notation is a blocker. Now, when you're living inside it, you don't realize that. But it turns out, especially when you're talking about numbers, that notation is, in the history of numbers, notation has been a real blocker. For example, before the introduction of place notation, it was really hard to express very large numbers. And that was a blocker. And comprehension, if it's too complicated, then the mass of people are not going to understand it. And computation is interesting because in Roman times, to do long division in Roman numerals took a PhD. So as a result, they wrote their numbers one way and they computed on the abacus. And so there was this friction between the written notation and the calculation, which slowed things down also. So it's important to understand that notation is a blocker, and what I'm going to do is basically propose and ask you to be open to the possibility that that can be true in software too. So this was my original thesis. So how is this going to happen? Well, if everybody's going to understand it, you can assume that it's going to be taught in elementary school. So in other words, we can use first graders as proxies for the population as a whole. So how are you going to give first graders a sense of what's inside an interactive application? You have to change the conceptual model. That's something that's available to them. Now, so the first problem you have is we have to stop thinking about software and we have to start thinking about people. We have to think about what is conceptually available to everybody. And the way we do that is to think of something that everybody has and then take advantage of that. And that's something that everybody has is the hand-eye brain system. Now, I realized this. It was a real breakthrough for me when I watched a grandson sitting in his high chair struggling to put a Cheerio, to put it in his hand and put it in his mouth. And I realized that nature has endowed everybody with this immense capability to build the brain. And it takes years. And what we have been given is the persistence to stay at it. And you see it with babies. And many of you know the name Maria Montessori. She's an expert. She's a pioneer in childhood education. And she has said that the hand is the pathway to the brain. So the hand is a big part of this. Now, you may recall if you read the blurb for this talk, it said something about feedback loops. Well, you're going to see feedback loops. There's a second feedback loop that you're going to see even more, and that's the feedback loop involving the hand, the brain, and the eye. Okay, now here's the premise. We are all born programmed with our bootstrap program. We don't know, the bootstrap program doesn't know anything about our body, doesn't know anything about the world, but what it does is explores, and it explores the world and it trains, we train ourselves, we build the brain, and we build the hand-eye brain system. That's the occupation of the child, and it goes on for years. So that's basically what we've been doing for the first few years of our life, is running this program. That's 3 generations of Conways, by the way. So you see more than hand-eye brain. You're seeing socialization, mirroring. And the child is just working like crazy, building the brain. Okay, so what we have to do then is think about software. We have to change our paradigm from software being an intellectual activity to being a manual activity. So the first thing we do is to realize that the person at a keyboard is not the model that we're looking for. Alan Prillis, who was an important computer science educator in the last half of the 20th century, said coding at a keyboard is an unnatural act. That's what you see on the left. The model that has inspired me is the potter. The potter with the hands on the material. Those are 2 key concepts, hands-on and working material. So I'm going to explore, what do these concepts mean in the context of software? Well, the working material is the stuff of the application, and if you'll suspend disbelief for a while, it's the stuff you have your hands on. Now, I've never figured out how to put my hands on an algorithm, and it seems to me that algorithms are not available to everybody intellectually. So what we need is a concrete model for software that's static, that is, we don't have to think about sequencing, and it's concrete. Now, it turns out we have to think of building changing not only the conceptual model, but the construction model, because we were all raised with file in, process, file out. And it's hard to put your hands on that too, But what the potter does is transform in place. In other words, you throw a lump of clay on the wheel, and then you slowly modify it in stages until you have the working artifact. So there's a change needed to the construction paradigm as well. Well, I've been thinking about this for decades, and I've come up with 11 principles for designing a hands-on tool. Now, this is a very detailed slide, and I'm going to go through it rapidly. It's not the point. I actually tweeted a paper called A Dozen Lessons in 50 Years, and at the end of this paper, I describe these in more detail, but let me go through them. So these are the properties of a hands-on software tool. And remember, this is aspirational. Some of it is present today, some of it is not. Unified, that means no source-object distinction. There's only one representation of the program. It's what you've got your hands on, and it's what's executing. Symmetrical, you see the thing you're building, and you see the tool right in front of you, and you can touch each one next. They're peers, side by side. Choosing over composing means no command line, no syntax, point and select. In other words, make a minimum demand on the user to compose, to think, to recall grammatical expressions from memory. You'll see examples of that, by the way, in the video. Always on, that's another concept that took me a while to figure this one out. When you drag a component out into the workspace, it's running. There's no concept while you're building the program, there's no concept of starting the program. Inspectable, meaning you can look at any value at any time. Changeable means you can modify your stuff at any time. And immediate means you'll see the results immediately. Reversible, if you don't like it, you can change it. Predictable, I used to say linear, but software is hardly linear. But if you want to make small changes, you should expect that you're going to get the results you expect. Transparent, the tool promotes, basically, ideally the tool disappears, and it promotes the illusion that you have your hand on the working material. Now, this is aspirational. We're still stuck with keyboards and mice and pointers, but there are some applications that are better than others at promoting this illusion. There are some page layout programs, there are some drawing programs on the iPad that are really very good at promoting this illusion. Interactive, it reminds me of when I was a child playing with my erector set. You are a child playing with a construction toy, the whole world has disappeared, you're in the zone playing with your thing. That's the ideal. So it turns out that there are three aspects to making building applications a manual activity. One is we have to have a model that's concrete and intuitive. We need hands-on tools. And as you're going to see, we need to develop with live data. Okay, here we go. This is the model that replaces code. It's a wiring model. That is, what's inside the rectangle is the program. What's outside, the user is at the right end, the data is at the left end. There are components in that white space that you wire up. The data flows from left to right, from data to user interface. So at the left end, there are database components, and the right end, there are projector components, and there's stuff in the middle which you'll see. Now, the projector components are interesting because it's an interesting metaphor to think about how to build a user interface. The projector components are the terminal components at the right end of a network that each one is responsible for producing a region on the screen. And when you think about turning data into a user interface, that's a very useful concept. For example, a dialogue is a projector of an object. Okay, so this is what you're going to see. You're going to see wiring diagrams, data flowing from left to right, database components on the left, user interface components on the right. And to demonstrate this, I'm going to build a simple order entry application. Now, what I did for data, I took the takeout menu of my favorite Italian restaurant, and I put it into Microsoft Access. By the way, you should know that what you're going to see was built in the 1992 to 1996 timeframe on Smalltalk, running on Windows 3.1. So it's a Smalltalk that hasn't been supported for 20 years, built on a platform that hasn't been supported for 20 years. It's running in compatibility mode on Windows XP in a virtual machine on my Mac. So there are many layers, but the only fragile stuff is the first two layers, which is the Windows and the Smalltalk especially. So to get a database, I used Microsoft Access. And I keyed, the menu was organized by category, so I had a category table. There are 6 categories: cold subs, entrees, hot subs, etc. And then all the items are in the item table, and there's a category column in the item table. And we're going to use the category to navigate into the item. That was the left end. At the right end, this is what we're going to build. We're going to build a list box, a category list box. So we'll have the list of categories. We'll select a category. This will display the items in that selected category. We'll select an item. That will display 2 aspects of the item: a text description and the unit price. And those are basically the things that are in the database. All right. And then we're going to be able to enter a quantity, hit the accept button, and see the computed total, which is called extended total, I believe. Okay. Now, hitting the order button would send it off to a shopping cart, which you're not going to see. So I think there are 11 projectors here. The buttons, by the way, that's another interesting concept. They're projectors too. As far as I know, all flow models of interactive applications, event-driven applications, have had to have right-to-left flows for events. I managed to find a way around that. So even buttons are projectors from left to right, but it's a special data type. It's called a do-it. And projections of do-its are things that take user events. Okay, so that's the left end and the right end. So my first message then is that you're going to see a direct path. You've basically seen the pictorial model of the application now. You're going to see a direct path to a running prototype. And the way that seems to work is you build the left end and the right end, and then you work toward the middle. Okay, now, in order to compute the extended price, and in order to have an object that we send over to the shopping cart, we have to create a third object, which is built from the second object by adding the fields in italics. Now, and also, I did not want to reflect the relational model inside. This is object-oriented programming. So these are really 3 classes. And the left-hand 2 classes, category and item, are images of the external database. The third class is built internally. But there's a symmetry among all 3 classes. And what happens in particular, you're not going to see any arithmetic here because the arithmetic is in the classes. When you enter the quantity, the extended price will be computed using the quantity and the unit price. Okay, here we go. First of all, I'm going to build a component that has the database components in at the left end. And in order to do that, in order to see what I'm doing, I'm going to build some scaffolding, which is a user interface for that. Later on, I'm going to remove the scaffolding and replace it by connectors. Okay, now there's the workspace. That's the component palettes. Here are the component categories. I'm just browsing the component categories at this point. I'm going to get down to a window projector, and then I'm going to drag it out onto the workspace. And as soon as it hits the workspace, it's going to be running. Okay? That's always on. So I'm going to drag it over, make room, and now that's the right end of my scaffolding. Now I'm going to drag out my database components. The first thing is what I call a namespace, which is actually a database. And there are 3 databases that I can access. When you select something and choose the thing at the bottom, I'm going to choose the Italian menu, namespace, okay? Notice when I touch it, there's a red box goes around that raises a command at the bottom. Okay, there are 2 data sets, which are tables. So first thing I'm going to do then is project, notice the language, I'm going to project the category table into a list box. There's the list box projector. Now, as soon as I wire it to the window, you're going to see the default rectangle there. And when I wire what have we got here? We don't recognize data because it's a record. So we have to tell it which field of the record do we want. And so we select it, we go back, we raise a dialog. Now, what field do you want? Those are the fields in the record. We're going to pick name. And notice that the values are shown. This is all part of giving the user all the information he needs so he doesn't have to use his memory. Okay, and it works like a database. Those are the categories. All right, now we're going to put the equivalent of a rotary switch in there so that when we select something, we can get the selected category out of it. That's a collection component. There it is. Now the collection goes in the left end, and it comes out the upper right-hand connector, and there it is again. Okay. The lower right-hand connector, that's where the selected category is going to come out. We'll use that later. But now what we're going to do is we're going to project the item table. And for a while, they'll be decoupled. Okay, choose the data set. There's the other one we choose. And we're going to do the same thing. We're going to drag out a list box projector, wire the item into it. There's the default box for the list box. And we're going to wire the collection into the list box, and we're going to have the same issue because we get records. So we select this, we open up a dialog, and we see these are the items these are the fields in the item, and there's the value we want. Okay, notice that Petrillo sub is not an entree because the 2 are not coupled yet. So we're going to put in a query component, which I call a slice. So we cut the wire. We're going to splice in a query component. Now, this is the best illustration yet of a projector because it's going to raise a dialog, which is a static equivalent of an SQL select statement. So again, it's no composition, choose. You'll see that soon. Okay, here's the dialog. Okay, the top is the vertical slice. First question is which columns do we want in the output? All. Okay, then next thing, and by the way, we're going to see the SQL that we're building down here. Okay, so we need a where clause. And we do that with a horizontal slice. We're going to category equals something. Okay, there it is. Category equals what? Well, we're going to get the what from that rotary switch that we wired up. So we're going to close the dialog, and we're going to wire the output of that top rotary switch into the second input of the slice component. But then again, we have to select which field we want to enter. And so we open up, this is a select field component. You're going to see this a couple times. And those are the fields in the category. And there, when we select it, there's entrees. We want entrees, so we'll select it. Okay, now at this point, this slice component has its input, so we're going to go back and look. There it is. We need quotes around the entrees, so there's a little checkbox that gives us quotes. Okay, now we have a query. And as soon as we make a selection here, we're going to see the result. Okay? So, that's what we've got so far. Now, one other step, we have to display the description of the selected item. So we're going to drag out a projector of a text line. And we're going to take the selected item and project that. And again, what you're going to see is a record as soon as I make a selection. So we have to tell the text line projector what field do we want. And again, we're going to see the values, so we'll know. We get some feedback about which one is the one we want. So there it is. And now we'll play with it a bit. All right, now what I'm going to do is remove the scaffolding and create a composite component from this. And I'm going to replace the projectors by connector components. Connector components are the flow equivalent of formal parameters in a function declaration. They connect the inside to the outside. And when you see the graphic for a connector component, you'll see that there's this wall that represents the wall that's going to get built around the whole thing. Okay. Now we enter two things. We enter a name and a help line. So we give it a name and we give it a help line. Now the help line, whenever you touch something in the workspace, it shows up here, so there's more feedback. Okay, now it turns out I'm going to build this. I'm going to speed it up a bit because I have 3 connectors. Turns out I made a mistake with this. I labeled the third connector description instead of selected item, so I'm going to reject the encapsulation, but I'm going to go through with it and then reject it. I had built one before, and it's going to ask, are you going to replace that one? And I'm going to say no, and I'm going to end up using that one. Okay, now I go up to the component menu, or the program menu, encapsulate to group 2. Okay, and we give the whole component that we're building a name. Do we want to replace the one that's already there? Turns out we don't. Okay. Now, we were done with the left end for a while. Now we're going to build the projectors, the 11 projectors for the right end. Now this is a repetitive job, and so I put all these projectors in a component without connectors. And you'll see that I never got around to building a WYSIWYG user interface builder, so I had to do it all by the numbers. Okay, I'm going to select, there it is as soon as I drop it. And now I'm going to open this up, and I'm going to, actually it's going to say zoom in and truncate, because I don't want that shell anymore. What I want are there they are. Okay, now, so all these all these projectors have sync connectors. Those are the input connectors. And I'm going to wire connectors to them all. And again, it's repetitive, so after the first one, I'll be speeding it up. So I give it a name, categories, and help text, syncs, that's the verb for sync connectors, syncs list of categories, okay? Then I wire it. Now you're not going to see any action over here because there's no data when I wire it. But later on, as soon as I connect the wire, you're going to see the data show up. This is all part of immediate feedback. Okay, then the second one, and then from then I'll go pretty fast. Now the third one is the selected item, and I'm actually going to wire it to two projectors, the description and the unit price. So you're going to see two wires coming out of here. Okay. And then we're going to encapsulate this. So we'll have a reusable component for the user interface and a reusable component for the database. So you've seen abstraction, by the way, in this model. Now you're going to see a Smalltalk bug when you'll see the one that I had built before, and there's something Smalltalk doesn't handle Windows bitmaps correctly all the time. There's a bit of a mess there, but I'm going to replace it. That's the component that I'm replacing. That's the help text. Choose item window wiring. Okay. And there it is. Now you notice when I touch the things, the various things, you're going to see the help lines come up. Okay. Okay, now it gets interesting. We've got the left end and the right end. Now we want to put stuff in the middle, which does the arithmetic and generates the order item object, which is what gets sent over to the shopping cart. So we're going to drag out our database component. And just to show you what's inside, we'll open it up. And there it is. You see the wiring is dressed up a bit because it was another one that I'm using. Otherwise, it's the same thing. And then I'm going to drag out the user interface component that I just built. And again, as soon as I drag it out, it's live. All right. Now, I'm going to project, the first thing I'm going to do is project the quantity field, but the quantity field is in the order item. That's the derived record that I'm going to produce from the item record. Okay, so we can actually play with this a bit. Now, notice that as soon as I connect the wire, the data is going to show up. And as soon as I connect the wire for the selected item, you're going to see the description and the unit price show up. There it is. Let's see when we connect the wire. Those are the two things that show up. Okay? So now we've got a working user interface that's a database browser. And we're going to get to the interesting stuff, which is creating a new record and giving it the few properties that we're going to have to it. And that requires a component called, let's see what it's called, new record. Now, this one is going to look at what's on its input, which is the item, the selected item record. And so the schema has the classes on the inside, and the classes know which classes are derived from other classes. So this knows that there are only two possible classes that can be derived from this input. So let's look at the output of this now. First, we're going to look at the input. We'll open up an inspector. And I'm just using Smalltalk inspectors here, so it's not particularly user-friendly. Okay, and you'll see the record as soon as I select it. Those are the fields of the item record. Now I'm going to look at the output, the right-hand end of this component, and you're going to see 3 additional fields. There it is. The quantity and the extended price and the order number, which doesn't get used. Okay, now we're going to project the quantity into the quantity field over here. But first of all, we have to select the quantity from the selected item. We have to choose the field from the selected item, and that's the select field component, which we've already used. And we open up the dialog, and we know which fields are in this, and you'll see the values show up. And as soon as we hit item, I think we'll see the actual item that we've selected. Okay, eventually I'll go back to clicking on item and then, oh, quantity, that's right. I wanted to project quantity. Quantity is blank at this point. Now, I could wire it right into the quantity projector, but then it would not be a data entry field. There's a component that makes it into a data entry field. And that component needs 2 projections. It needs the value, and it needs the do it, which gets projected in the accept button. So that's the signal to actually go back and take the value in this field and put it back in the record. That's what this component does. Okay, now there we're playing with it. Now we've put in a quantity field. Let's see if it actually changed it in the record. So we'll go back and inspect the record. That's the output of this component. And you're going to see the quantity 3 and the computed price. There it is, the quantity 3 and the computed price. So the thing is doing what it's supposed to do. And this, by the way, is the style of building software that I envision. You know, you play around, you get something, you play around a little more, you get something more. Okay, now we're going to project the extended price field, which is already there. You saw it in the record, and as soon as we wire it to the projector, it'll show up. But first of all, we have to select the field in the record. Extended price, and there it is, same value. Okay. So we're going to select that one, go back to it eventually, and click the Done button. And then we're going to wire it to the projector, and you'll immediately see it. There it is. Okay. That's our application, by the way. That's it. And we're going to play with it a bit. Okay, that's it. Now, notice there really wasn't much there, which is kind of nice. Now I'm going to discuss the implications of this. Okay, so the second message then, you've already seen the first message, which is there's a continuous process for going from pictorial description of the application to an actual running prototype. Now what I'm going to do is show you that this particular flow model partitions the application into parts which require coders and parts which don't require coders. Okay, in other words, I'm going to create a common space for domain experts and developers to work in the same space to build a prototype together. Now, as a side issue, I want to describe a corollary to Conway's law, which I've never published. And that is that when you have stable interfaces, you can have groups, design groups building to the interface without any knowledge of what's on the other side. And in fact, you can have groups with different languages, different cultures, different worldviews, different educations, different vocabularies for their field, and they don't have to have any knowledge of each other if the interfaces are stable. Now, this is the model for that. This is the interface between two system parts, part A and part B. The left-hand side is the people side, and this is the right-hand side is the thing side. Artisan and artifact is the term I use. Okay, so this is a builder of system part A, this is system part A, builder of system part B, system part B. In the middle is the interface. This is the team that defines the interface. This is the interface itself. Okay, we're going to keep that in mind. And just to show you that, okay, it looks trivial, but it's not trivial, because there's a classic example which we're all familiar with, and that's the technology stack in a personal computer. And described in this model, it's a big thing which I had to break in the middle, and it goes all the way from the user at the top to physicists at the bottom. Now, the skills involved in the artisans, and by the way, I've switched the left and right in this particular one. Okay, what do we have? The skills: users, application programmers, system programmers. What have we got over here? Computer designers, electrical engineers, and physicists. And now, this is actually in existence. This is how physicists and users talk to each other through these standardized interfaces. And we're going to take advantage of that. Okay, now this is the application again. I've flattened it out a bit by putting the middleware and the projectors at the same level. Now, what I'm going to show is that this can be partitioned in an interesting way. These are the dotted lines that partition the whole application into three parts. At the left end is domain object heavy, takes developers. At the right end is domain object light. In fact, it takes no coders. This is just the user interface. In the middle is this middleware, and I call these session object components. And it turns out that what this part is basically an editor of this part. So using this program model, you're interactively building an editor of some objects over here. So this is the first observation. Now, there's one more component which I haven't talked about, and that's the message component. And this is the basic interface between the wiring diagram and the domain objects. This component will send a message to a domain object. The domain object is the receiver that shows up in the top sync connector, a couple of arguments. Okay, you'll click on this thing, you'll see a red box around it, a dialog will open up. You'll see the messages that this particular domain object can accept, and none other. So it's always selection. And this outputs a do it, which when you select it, when you click on the button or whatever, the message gets sent. If it has an output, the output gets sent here. So this is the interface between the wiring diagram and the world of domain objects. So here's the opportunity. You've seen this. The wiring tool is a common space where domain experts and developers build prototypes together. But this is the thing that isn't quite so obvious. Wiring diagrams and dialogues form a distributed but a clear interface across which domain experts and developers cooperate to build different parts of the prototype. This is what the developers build. They build the domain objects, they build parameter objects that will be projected into dialogues that are the dialogues you see when you say, what message do I send to this object? You open a dialogue, this will list the messages. You'll make a selection that will fix the value of this parameter. The message will be displayed here. Now it's set to send that message. Okay, that's what developers build. What domain experts do is they build wiring diagrams, they encapsulate the wiring diagrams into new components, and they fill out dialogues. And this is what the developers build to support that. Okay, now the same old model tells you how this works out. At the top, again, we have people on the left and things on the right. At the top are the developers, and the artifacts that they build are domain objects, primitive components, parameter objects, and parameter projectors. Down at the bottom are domain experts. They build wiring diagrams, composite components, and dialogue bindings. In the middle is the interface between these two, and the interface between the developers and the domain experts is the joint design team, and what they build are prototypes. So this is actually a model for creating a workspace in which all members of the design team can work together to build a prototype. And that's the message. Okay. Now, I actually have this thing running on my laptop. I'll be carrying it around. I'm available on Twitter. Notice the underscore. If you leave out the underscore in my Twitter handle, you'll get an Irish law firm. And there's my email address. And I haven't done it yet, but I've been documenting this thing for a while, and I'll be posting the documents. So thank you very much.